Good day, sir. I'm proud to present to you my select article entitled The Effect of Silotype and Dry Matter Content on Maize Silage Fermentation Process and Ensiling Losses by G. Sicato et al. Introduction. The utilization of experimental silos as a method of evaluate the forage fermentation process and ensiling losses has been widely discussed by Barnett 1954, Wolford 1984, Sicato et al., and MacDonald et al. In previous studies, we reported some result obtained using different types of experimental silos. These silos can provide adequate response for certain objectives. The evaluation of ensiling suitability of forage and agricultural or industrial byproducts, the control of ensiling and effluent losses, the assessment of the ensiling process during a short or a long period, this conservation of a quantity of forage sufficient for feeding trials to evaluate silage nutritive value by Parigibini and Sineto 1982 and others researcher. Experimental silos are movable to facilitate evaluation in various locations and are inexpensive to permit numerous replications. However, what is more important is the possibility of evaluating forage mixture in different proportions, comparing the effect of additives in varying doses. One of the most important objections to utilization of experimental silos is the ensiling process in such silos has not been proven to correspond to that of farm silos. Possible causes of the difference between farm and experimental silos are different degrees of compression of the ensiled materials, different airtight sealing with the possibility of losing the fermentation gases, and the presence of effluent collecting equipment. Other objection to utilization of experimental silos concern the possibility of identifying the chemical differences between the samples derived from farm and experimental silos, owing to the limited quantity of materials utilized in the latter. In fact, it is well known that during farm ensiling, the forage chemical compositions can change according to the harvesting area, the exposure, the quantity of the soil, and the water availability. In particular, the moisture content plays fundamental role in ensiling process and loss and overall silage quality. The main purpose of this work was to compare three types of experimental silos with several farm bunker silos to evaluate the correspondence of the results gained in the laboratory and at farm. A further objective was to establish correlation between the dry matter content when maize was harvested and its fermentation pathway and ensiling losses. So, this study, the gap of this study, the main gap in this study is the lack of investigation into the specific of different silotypes and dry matter content on maize silage fermentation process and ensiling losses. The study aimed to address this gap by comparing the impact of experimental silos and farm bunker silos on the fermentation process and ensiling losses, specifically in relation to the dry matter content at harvest. By examining these factors, the study sought to provide valuable insight into optimizing the production and quality of maize silage. So the more the corn is matured, so the dry matter will be low. Then the materials and methods. maize harvesting and silo filing. This experiment was conducted with whole chopped maize plant from 4 farms located at the same village in the Venetian Supoli in northern Italy, and similar both in the quality of silo and exposure. The attempt was made to duplicate faithfully the normal harvesting condition of maize plants, which can vary very greatly in a chemical and morphological characteristic. This maize was harvested at maturity stage according to this time and techniques usually in each farm, even if there were no great differences among these. Maize plants were chopped to a length of about 10 millimeter, and a material was immediately taken to the farm where both bunker silo and experimental silos were prepared at the same time. So 3 types of experimental silos were tested. First, the S100 silo 100 or 1 capacity. This silo was plastic dustbin modified by a valve at the ground level to collect the effluents. The rough material was compressed by trampling it down, and the silo was closed with a polyethylene sheet fastened by a plastic cover, no airtight sealing. Another types of silo, 500 1 capacity. This pilot scale silo was made of plastic and had a height of 1.5 meter and an internal diameter of 1 meter. It had a valve at the bottom to permit the recovery of effluent. Chopped maize was compressed by trampling it down. This silo was sealed with a hermetic cover with a valve which permitted the escape of gases but prevented the entry of air. Then the next types is A002 silo or 2-1 capacity. This micro silo was a glass jar for food preserved with a special plug that permit the escape of gases and prevented the entry of air. So there are 12 experimental silos for each farm. The quantity of chopped maize required to fill the experimental silos was about 50 kilogram. Another is 25 kilogram and 0.9 kilogram, respectively. The experimental silos were kept inside the unheated room for 6 months. So 6 months ang iyahang fermentation process. During the entire period of conservation, both the possible release of effluent and the correct closure of the experimental silos were controlled every 2 weeks. Sample collection and analytical procedure. The first material was sampled when the bunker silo were initially filed. 4 samples from each of the 3 pie plots were collected. When the experimental silos were opened 6 months later, 12 samples of silage were also taken from the bunker silo over a 1-month collection period. With the exemption of the determination of the dry matter content, all the other analyses were performed after gathering the samples by 2 by 2. The approximate chemical composition of fresh and ensiled chopped maize was determined following standards and methods. So we have Association of Official Analytical Chemists, or it is a group of chemists. The fiber fraction, the neutral detergent fiber, the acidic detergent fiber, acidic detergent lignin, or can be described as a fiber. Acid insoluble ash, or EIA, were analyzed after the amylase pretreatment by the during and Van Soot method of 1970 as modified by Robertson and Van Soot 1981. So then cellulose was calculated as ADF, or acid detergent fiber minus close and open parenthesis acid detergent lignin plus EIA, or the acid insoluble ash. As regards starch, the sample extract was carried out following the Hilliard and Linyard methods, and the concentration was obtained by colorimetric determination by Blackini and Muto 1980. For the analysis of fermentation characteristic, the sample were extracted with a lab blender's stomacher 400 or Seward Medical London using both distilled water for pH determination and H2SO for 0.1 and solution by Canel et al. 1984, Sicato et al. 1990. The acid extract was analyzed by the High Performance Liquid Chromatography or HPLC using a biorod. This apparatus permit measurement of the volatile acid, the lactic acid, the glucose, and ethanol concentrations. Ammonia was detected in the some acid extract by using an Orion-specific electrode or Orion Cambridge MA. The dry matter content of silage was corrected in the basis of organic acid, ethanol, and ammonia using an equation regression specific for maize silage as suggested by Dolphy and Dimarchili 1981. Statistically treatment of the result was performed by the covariance analysis with the release square mean method of Harvey 1990. Result and discussion. Chemical characteristic of fresh and ensiled maize. The lower maturity of maize from this farm is confirmed by the low percentage of starch. So if the low maturity ang corn, so natural low percentage po siya of starch nga mo produce. And the other hand, the higher glucose content. So the more nga low maturity, so the higher glucose content nga ang i-produce sa corn. According to Giardini 1970, Wilkinson 1978, and Papigi Bini 1983. The chemical characteristic of ensiled maize were obviously influenced by the farm effects. So the ensiled maize can be influenced, depend on the management of farm produce. Kung paunsa niya gi-produce ang iyahang maize plants. Given that they were closely linked to the composition of the fresh chopped maize, the moisture increase in the silage contained on experimental xylose is linked with a greater fermentation activity. So the more nga taas ang moisture, the more siya nga the greater of fermentation. So the more nga mas quality ang produce nga silage. As have been shown also by the other worker and Anderson and Jackson 1970, Perugini 1984, Sicato et al. 1990, AB and McDonald et al. 1991. Fermentation characteristic and quality of maize silage. Result concerning the fermentation product and quality evaluation of maize silage. So the result concerning on the fermentation quality and evaluation of maize silage process. All the fermentation parameters were significantly affected by the types of silo except for butyric acid. So the fermentation parameters can be significantly affected to the kind of types of silo sulayan except for the butyric acid. The butyric acid, it is produced, or it is a bad organism inoculated to the forage fermentation. So ang iyahang odor foul odor ang iyahang ma-produce. Next is the largest difference were found between experimental silos in the whole and bunker silo. Generally speaking, bunker silo is shown as a lower pH than the average of experimental silos. 3.58 versus 3.70 ang iyahang acidity content and the lower concentration of all the fermentation product. This result can be explained by the greater rate of compression in bunker silo, in which there is generally a faster decrease of pH and earlier end of fermentation activity. So involve S100 and S002 silos, their differences might be due to the different rate of compression. So the more the compression will produce, so the more fermentation will produce quality silage. If there is poor compression, so we can achieve low fermentation forages can be produced, which is lower in S002 silos or to different sealing system, which has no absolutely hermetic in the S100 silo. The production of organic acid, except for the propionic acid, was similar in the three experimental silos, where ammonia 4.93% and 5.42% versus 6.73% total nitrogen appeared to be inversely correlated with the density. On the other hand, ethanol production was observed to decrease the degree of airtight sealing. Results agree with those of others. The ethanol levels decrease as the oxygen level decrease. If the oxygen level decrease in the process of making silage, so the ethanol levels will be decreases. So according to Walford 1984, McDonald et al. 1991, the entity of homolactic fermentation in comparison with the heterolactic pathway can be properly represented by the homofermentation index. So the homolactic fermentation start with 1 to 20 days homolactic fermentation. Then after the homolactic fermentation, so undergoes the heterolactic fermentation process. And this ratio between lactic acid and some of the acetic acid and ethanol, and it seems to be influenced by the silo in sealing system. So if we conduct forage fermentation, this kind of lactic acid and acetic acid and ethanol will be produced inside the ensiling forages, and it seems to be influenced by silo sealing system. So if the sealing is poor, so the lactic acid production, acetic acid and ethanol will be also poor. So next, the homofermentation index was 2.12 versus 2.62 and 2.70 respectively for S100, 500 and S002 silos, which were characterized by progressively increasing airtight sealing in the bunker silo. The value for this index was 2.83. Initial moisture also significantly influenced the fermentation pathways. As is usually observed, several other researchers have found a decrease in the production of organic acid and ethanols in addition to an improvement of the silage quality. As the silage dry matter content increased, according to Andrew 1976 and Giardini et al., another researcher. Ensiling losses. So in making of forage fermentation process, so we have ensiling losses. The total losses of several chemical compound was not so easily explainable. First of all, we observe an increase of ether extract caused by the production of ether soluble metabolites during fermentation. So according to Van Zoot 1982 and others. On the other hand, the increase of crude fiber 2.8% and the loss of certain fiber fractions in experimental silos may be due to chemical changes occurring during the ensiling period and or to analytical errors, which are very common in the Van Zoot and Windham methods. The pH values increase for 3.80 to 3.95 when the dry matter content of silage varied from 30 to 35% to 35 to 40%. The lactic acid content decreases from 4.85% to 4.67% dry matter. The acetic acid content decreases from 1.34% to 0.93% dry matter, and the ethanol content decreases from 1.28 to 0.47 dry matter content. So the more the pH will be decreased, the more you can produce the quality silage. If the pH will increase, so the more na acidity will be increases, so it will harm the animal health if the pH level of the silage fermentation will be increased. And similar to the fermentation product, the ensiling losses were significantly correlated with the maturity of maize when harvested. From a practical point of view, only the estimation of total dry matter loss was interesting because all chemical compounds show the same curvilinear trends. Premature maize harvesting causes very high substances losses owing the excessive fermentation. So, kung premature ang maize nga i-harvest, so ito po posible nga there is an excessive fermentation and losses. On the other hand, delayed harvesting causes progressively higher losses owing to difficulty to chopping and compressing the forage and excessive decrease in fermentable sugars. So, pag sobra na po siya sa iyang edad, so lisod na siya i-chop, then maglisod daw compress. It's because of over-mature. The effect of initial moisture and the fermentation and loss can be linked, at least partially, either to influence of dry matter content in silage density and those on oxygen availability during the first period after ensiling. So the quantity of gas exchange during conservation. Conclusion: the variability of maize composition among within the farms explain a part of the difference and fermentation characteristic. Other factors that influence the fermentation pathways are the different rates of compression. So, different rate of compression. So, the more nga i-compress nimo siya, the more nga quality ang imuhang silage nga ma-produce. Kaya there is no presence of air within the silage fermentation. So, kung naa siya air, so the more nga low quality ang ma-produce. And the different degrees of airtight sealing in the various type of silos. Among the three types of experimental silos, the 500 flat scale silo is preferred because it has a suitable airtight sealing, and because of this fitful reflect real farm silos conditions. The silo has an effluent collection valve and can be easily modified to detect the gas exchange. In addition, it can store enough forage to permit feeding trial. The S002 silo is more easily handled than 500 silo and has a very low cost. Therefore, it is practically appropriate for the study of fermentation kinetics and for frequent control of different times after ensiling. The perfect airtight sealing of this silo make up for the lower compression that can be reached inside. Lastly, the S100 silo can be used even if it is less effective than the other two and it lacks of airtight sealing and consequently permits higher conservation losses and more pronounced heterolactic fermentation. This limitation can be easily overcome if more airtight sealing is provided. So, if there more airtight sealing in making silages, so the more quality forage ang imuhang ma-produce. The initial dry matter content was the most influential factors in the fermentation process and ensiling loss. The optimum dry matter content at harvesting required to minimize the losses was 35% ang iyang dry matter content sa silage. The limited variability in dry matter content and the chemical composition of maize harvested in this experimental could explain the strict relationship in the chemical composition and fermentation quality among the different silos. Then the end of the report. So this article, the gap of this article, so atong balikon. The main gap of this article is the lack of investigation, so dila sa na-concretize ang iyang observations about sa tawagan na about sa type of silos. So by examining the factors of silo to provide valuable insight to optimize the production and the quality of maize silage. So gina-undergo pa nila og observe or study on how to make silage fermentation with high quality and high nutritional value. And that's all. Thank you.